Okay, so to solve these two equations to find the values of a and b, one can do the one can multiply this second equation by uh, minus m omega square kb. Okay, so I multiply this equation by minus m omega square kb and divide by omega c. So what I will get is over here minus m omega square plus k times a. So and then omega c will be divided. So it will be minus m omega square plus k square divided by omega c, that is b, equal to 0. So now I get this third equation. So now I will add these 1 and 2 equations in this way. Then these a terms will be cancelled out. Okay, so only the b terms will remain. So I will get is omega c plus k minus m omega square. Yeah, I can square over omega c is equal to f naught. Okay, so multiply both sides of equation by omega c, so that I will get omega square c square plus k minus and that this will be b will be common. Okay, so b will be common, and omega square c square plus k minus omega m omega square square, and then I am multiplying both sides by omega c, so it will be f naught omega c, and then this will be b. Okay, so the value of b will be then thus f naught omega c divided by k minus m omega square plus omega square c square. This will be the value of b. So to find the value of a, then I can use this equation number 2. So in this equation number 2, it will be minus omega c. Then it will be I can write it like k minus m omega square, and the value of b is f naught omega c divided by k minus m omega square plus omega square c square, and that was equal to 0. Okay, so then in this case this will be omega c times a. Okay, a. So from here I can take this omega c, I can change the signs of this omega c term. So omega c will cancel out from here. Okay, omega c will cancel out. So what will be left is, if you will simplify it, so it will be f naught, because omega c will cancel out, both terms have it, and then I will get this value. Okay, so a will go over that side, so a will be equal to then this k minus m omega square, and then k minus m omega square plus omega square c square. So this will be the value of a. So we know that now omega naught is equal to square root of k over m, or k is equal to m omega naught square. Okay, this we know from the free oscillations, modeling for free oscillations. This is the natural frequency omega naught over here. So in this case if we can input these values into the expressions for A and B, then how can we put it? So for example, k is equal to m naught, m omega naught square. So A will become f naught into m omega naught square minus m omega square divided by k minus divided by, so now k, the value of k is m omega naught square, and then m omega square. This was omega, m omega square plus omega square c square. So this will become because if I take m as out of this equation, so f is equal to I can write it in the next part. So now A will become f naught. So one can take m as outside of this equation. So it will be omega naught square minus omega square. Yeah, m is taken out. Similarly, I can take m out from the here. Okay, so when m will come out, so it will be m square. Then it will be omega naught square minus omega square, and plus omega square c square. Okay, so in this way it can be represented. And b is like always f naught omega c over in this case for the b in a similar way, so we can represent k by m omega naught square. So it will be m square omega naught square minus omega square plus omega square c square. Okay, so now we can now we already know the values of a and b, and then from determining and then the particular solution can be determined. So anyway, so if we go back to the initial condition, for example, if we go back to the original equation, which was m y double prime plus c y prime plus ky is equal to f naught cosine of omega t. This was the original equation, and we were talking about the solution of this equation. So in this equation, if we say that if c approaches to 0, that means c is negligible, so then we will have this type of equation: my double prime plus ky is equal to f naught cosine of omega t. So when c is 0, so how these a and b coefficients will change? So in this case, a will become, so when c is 0, okay, so a will become this, c will become 0, so this term will vanish, and then m and m will also cancel out, so m will remain in the denominator. So it will be, so a will be then f naught over m into omega naught square minus omega square. Okay, so yeah, some correction. This was omega square, and then this is omega square. So here it will be just a power of 1 will be there, and in that case b will simply become 0 because c was 0 in the numerator. Okay, so the solution then can be represented by, so since the solution is yp is equal to a cosine omega t plus b sine omega t, so therefore because now b is 0, so the solution can be represented by yp is equal to, for a particular solution can be represented by this value of a f naught over m into omega naught square minus omega square times cosine of omega t. Okay, or in another word, this equation can be also written as something like this: f naught, and then if we take omega naught square out from this equation, omega naught square out from this equation, so then it will be 1 minus omega over omega naught square times cosine of omega t. So omega over omega naught. And then if we represent omega naught by omega naught square by k over m, because omega naught was k over m. Okay, so omega naught square will be k over m. So this m will cancel out also. So f naught and then m, that is k over m into 1 minus omega over omega naught square. This one cosine of omega naught omega t. So then we can say that yp is now f naught f naught k into 1 minus omega over omega naught square cosine of omega t. Okay, cosine of omega t. So in this way we can represent the equation, the solution of the undamped situation in the, when there are forced oscillations. Remember that the frequencies, when we talk about the frequencies, so the omega, these omega terms are related with the frequency. So for example, frequency is this omega, because the total is 2 pi, okay, and then the frequency will be represented by omega over 2 pi. So this will be the frequency of the force, external force, and the natural frequency will be equal to omega naught over 2 pi. Okay, natural frequency will be omega naught over 2 pi. The general solution is equal to the homogeneous solution plus the particular solution. So this general solution then can be represented by the homogeneous solution. Earlier we have seen, for in the case of the free oscillations, the general solution can be represented by this equation: c times cosine of omega naught t minus delta, and the particular solution that we just have written down over here is f naught is equal to, we can use either of these two equations or even this equation as well. Okay, f naught in terms of m, omega naught square minus omega square, in this case cosine of omega t. Okay, and so we will continue it in the next video clip.